Thermodynamics deals with the relationship between different types of energy and heat. Heat is the result of small, fast-moving particles transferring heat energy between two objects. This transfer is usually due to the difference in temperature in the two objects. The equation is heat equals mass of object times the specific heat capacity times the change in temperature. Energy is the capacity of a physical system to perform work. There are many different types of energy, including potential energy, kinetic energy, and thermal energy. The first law of thermodynamics basically states that energy cannot be created or destroyed. It can only be transferred or converted from one form to another. The second law of thermodynamics is that heat cannot spontaneously transfer an object from cold to hot. There must be a driving force causing this transfer. The third law of thermodynamics states that no object or system can have a temperature of 0 Kelvin because it will draw in surrounding energies before ever hitting 0. The zeroth law of thermodynamics states that if two thermodynamic systems are in thermal equilibrium with a third, then they are all in thermal equilibrium. Thermal equilibrium is when two different objects transfer energy until they can't anymore, staying at the same temperature with nothing to give each other. Exothermic is the process or reaction that has a release of energy from the system to its surroundings, typically in the form of heat. Endothermic, however, is the process or reaction in which the system absorbs energy from its surroundings. After an endothermic reaction, the object itself would feel warmer while the surroundings would feel colder. Exothermic makes the object feel colder while the surroundings feel warmer. A phase change also has a lot to do with thermodynamics. Phase change is when a substance changes states from solid to liquid or gas, and vice versa. The ways to conduct a phase change are condensation, freezing, melting, vaporization, sublimation, and deposition. Enthalpy is a measure of heat in a system. The equation is enthalpy equals the amount of internal energy plus the pressure multiplied by the volume of the system. Enthalpy also tells whether or not it's endothermic or exothermic. An example of an enthalpy experiment is one that we did in class. We took 3 different alcohols to see which one was more effective. Using the equation for enthalpy, we calculated that methanol was the most effective of the group. Entropy is a measure of the number of possible arrangements that atoms in a system can have. Entropy is often described as the measure of disorder. The more molecules there are, the more disorder there is. To explain spontaneity, I have to explain the equation of Gibbs' free law. The equation is the rate of enthalpy minus temperature times the rate of entropy. Whether or not the result is positive or negative tells how spontaneous the reaction was. If it is negative, it is a spontaneous reaction, and if it is positive, it is a non-spontaneous reaction. That was the basic rundown of all you need to know about thermodynamics. Thank you for watching.
Created using Powtoon.